Hey everybody, let me talk in this video how we do implement for heap sort algorithm, which is most interesting algorithm and you have to use it in all your sort operation. So to get started, I just create a new class. I will name it heap sort. Here you go, heap sort, and I would not create anything, just heap sort. So what do you think I would have? First thing you would have to have it. I would define static integer for total. Hopefully, I just started wrong. I don't know. Static integer for total. Okay, this is total. You would understand what total mean later on, but this is, you will see it now. You don't worry. Then we say the most important operation we do it in the heap sort is heapify. So let me define the method for heapify. So static. Why static is wrong? Static void doesn't return anything. So name of this operation heapify. Okay. Hopefully, yeah. Heapify now. Heapify is correct now. So what do you think this heapify would take? Take array and then try to do sort until get the last element outside the array. So I would not define array. I would define comparable because easy for me to follow the data. So I would define comparable of array. And I would not define normal array. I define array that could compare their element. So in this way, comparable of array, and I would take integer for I mean the index of element that I want to swap it. Here you go. So yeah, next let me just implement this method. So to implement this method, I would say first of thing you need to get left and right. So I say lft equal I multiply by 2 left node, and integer lrgt will be for sure I multiply by 2 plus 1. This is next element. So let me suppose integer grt should be the element I. This just help me to keep track if the element get replaced or not. So I would replace it with the new one. So if there is no change happen, that means the element is still in same place. Yeah. So how I do the comparable operation, or how do I comparing two elements then swap them? So to do that, first of all I say okay, if lft less than or equal total you will see it later, the total element that I have it, and array for left lft is if I compare it with compared to the object that array for grt is this less than, that's mean hey you need there's some change, or greater than 0, that's mean hey if this object, that's mean the element in the left, greater than the father or the parent, that's mean hey there is some process will happen. If we suppose grt equal the lft, that's mean hey if the, you remember when you talked about the node, you say okay if I have this node and this two node, so he say hey if the node that's in the left greater than parent, so hey you need to swap it. Okay, get it? Cool. So I just give notifications that you need to swap it. I will do same process for the right. I will say okay if it's better for me to copy this line and just replace left by right, I say if this is right still have to be less than total, and if array for right let's compare with if array for right compare with grt, not this one. If array for right compare with the grt greater than 0, that means also grt will be equal left. That means hey if there is also, if I compare the one who are on the left, so this one is still, if it's greater than, so I need to do swap. Okay, cool. So now yes, we do this process. Now let me go next and say yes if the grt is not equal for I, and I will go this process again. This I'm sure you say okay why is greater than should be less than, but wait a minute, we will go back for it and show you the different result. So yes is not equal, if this one is not equal this one, that's mean if this one is equal, that's mean there is no change happen, that's mean they are already balanced. But if any one of them is not balanced, so this value should be changed. So if there is no equal, that's mean there is, you have to do swap either with the left side or with the right side. Okay, so to do swap, you say okay, first thing you need to do swap. So you say swap between what? Between array for I and array for GRT. I will implement swap operation, and then continue heapify, call heapify. Heapify, what you send array and you send GRT. That means the new index. So swap method need to be implemented. So you say okay, static void swap, take two things, take comparable, and comparable should be here as array also. So also take integer for A and integer for B. There's two elements to get swap them. So how you would swap any two element? For sure you define comparable. I don't know why he always give me this one. You do comparable for temp equal array for A, and you say array for A equal array for B, then you say array for B equal temp. Just swap operation. I didn't did anything magic, just swap between two elements. Then here you go, swap and continue, swap and continue, swap and continue. This is how heapify work. Is basically you have this 3 node, for example. If you find this node is greater than the parent, so I need to swap it. So yes, you can do that GRT. That means if GRT is not equal I, so hey, send I and GRT swap them. That means swap this one by this one. Then continue heapify from this point. Then he will start compare this one and this one, and he continue. And this is basically heapify process. So yes, this is how you do heapify. Now let me go to the sort operation. So now I understand how to heapify for one element, but now I need to understand how I could do sort process. So to go down, I would do sort. So I say static void sort. So when I sort it, I have to do sort. I just get comparable again. I don't know why comparable always I get it. Okay, someone sent me array and asked me to sort this array. So I will say okay, static sort comparable. Someone sent me array and asked me to sort it. So how I would sort it? First of all, I just get total. Do you remember we defined the total? Total means the total element that I have. So I say total equal array dot length -1. Why? Because when you said okay, I have this array, and this element that I added in the end, when you just swap, finally you get this element. Should be the short one or the less element. Now you need to move this element to the end and take this one to the first. Then you don't need to compare with this part, so you need to take total -1. So that means you need to do heapify only on this part. For that reason we use total. So did you get it now? That's cool. So if I now I say for integer I equal total over 2, I do heapify from 2 over 2, then I greater than or equal 0, then I minus greater than or equal 0. I don't know why total this way. So then I do heapify. This means when you just first time you take the array, you need to do heapify for the array, because array is not balanced to be heap array. So you need first thing before you start, you just take them from the middle and you try to sort them. You just take it from the end and try to sort this part. This is before doing any heap operation. Now when you're done, yeah, now I want to do, now my tree is prepared to be heap tree. So I say for integer I equal total, still total, then you say I greater than 0, then you say I minus. So yes, now this is the important process. First of thing, you already have the array sorted. You already now have the first element in the array should be the shortest one, so you need to move it to the end, and you take the end here and you start do heapify only on this part. Then you continue do same process, take this one to the end, this one here, and do heapify only to this part and continue. Yeah, so how you do that? So first of all, you do swap between what? Between array in location 0 with array in location I, because I is the total last element. So then you say total minus, because you will not need to go to that location again, as I told you. Then you go to the next, you do heapify again, heapify for the array with 0. Why with the 0? Because you need to heapify with the first element only in that array. Now everything is cool. I have sort, I have if, I have everything. Now let me just implement the main method that that we will use it in this sort. So if you go to bubble sort, if you see here, I have this as main method. Just copy same main method. I just want to use same main method to don't lose my time. Here you go. Main method, you define array. You just print array before sort first, then you need to do sort. So you just call sort process. You say sort. Hopefully the sort work now. Hopefully this sort, no, small letters. So you're just calling sort method for array to do sorting. Then yeah, this is the sort. Comparable is array, so you need to define comparable array. This integer cannot be compared if you define it as integer. Have to be integer, because comparable type not work with int, work with integer. Integer, if you go to the integer class, you would see there is comparable already implemented. See, so you could use it. You could compare to this element, if you remember when you discussed about comparing. But integer only doesn't have comparable, so just compare, send it, then you print. I would not print the array, because now the sorted array will be, I think, no, I print the array also. Yeah, yes, I'm okay, sorry. So now if I just click run, here you go, 1, 10, 13, 15, 16, 18. This is basically how you sort the array. But one thing, you say Heapify, you told us when you talk in the lecture, you say I have 3 node. If I just talk about it here in this way, draw. Okay, you said I have 3 node. If this one greater than this one, that means left side. If this is greater than the origin, you do swap. That's okay. This man is correct, so you don't have any problem here. But here, why you did same condition? This is because comparing operation, when I compare object with next object, I would have this problem. So it's better when you compare object with next object, use same concept. So this is from Java, that structure. I want to go through it. So if you think about say, okay, this one, what you think about it as a normal process, you say this one, if this one is less. So when element you have it in the right side be less than that element, what the result should be -1, should be equal -1. That means be less. Is that right? This is less operation. So let me run it and see. See, he ordered for you, but he ordered in discrete order. That means he first thing take Heapify for the last element first. That means now if you follow the procedure that we do it in the keyboard when we talk about it, when we write everything, we was taking only first element. Did you remember when we just draw the tree? We just take last element, move it here, then move it here, then you have this element, then you take it out. So always this element be last element. This is if you follow that process. This is the correct process that we discussed in the book. But in the blackboard. So but if you want to be order and increase order, this is discrete order. If you want in a discrete order, you would say greater than or equal 0. And this is just, as I told you, this is just concept. Use the one that say this one 110. This is increase order. That one was decrease order. So yes, follow anyone that you think is good. If you want to order discrete, do this process. If you want increase, do this. If you want decrease, do that. And we're done, and thank you for watching.